Everybody's quiet on set, so we're good to go. All right, so we're multiplying and dividing fractions, which should be a celebration because it's so much easier than adding and subtracting. We don't need to worry about common denominators or common numerators. I don't think I've ever heard of that. What we do when we multiply two fractions, so we just multiply straight across. Numerator times numerator, denominator times denominator. So just multiply straight across. 3 times 2 is 6. Multiply 5 times 7. 5 times 7 is 35. And then simplify if possible, which doesn't look like you can. So that's your answer. It's that simple. Multiplying fractions, multiply the top, multiply the bottom. All right? If you see something like this, let's say it was 3/5 times, I don't know, 4. Okay? Oh, well, here's a fraction times what looks to be a whole number. But you can actually make this a fraction. You can just make it 4 over 1, because 4 divided by 1 is 4. So we haven't changed the value here. So if you ever just see a number, and it's like that on the other side too, you can make it 4 over 1 over here. It doesn't matter if I flip these around. And then from there, you just multiply like you normally would. 3 times 4 is 12, 5 times 1 is 5, and then simplify if possible. This is already simplified, so you're good to go. So multiplying straightforward like that. Dividing, however, so let's do like a division problem. Divide by, I don't know, let's do 2/7 again. Did we do 2/7 last time? Yeah. 2/7, okay. So when we divide, I can't dive too deep into this, but basically you're going to keep this one, you're going to change the division, and you're going to flip the other fraction. So I remember in middle school I heard keep, change, flip. That's the way that it was. So keep the first fraction, 3/5, change the division to a multiplication symbol, and flip the second fraction around. Okay? I apologize for not diving deeper into the why all this works. That maybe would be a good experiment. But for time's sake, this is what we do. We basically change our division problem to a multiplication problem and flip the fraction. All right, so we're inverting the original division, and we're inverting the other division part. So this gets flipped, or switched, this stays the same. And then from there, it's like what we just did. We just multiply straight across. So 3 times 7 is 21, 5 times 2 is 10, and then simplify if possible, which I keep getting things that can't be simplified. So that's our answer. If you see division, make it multiplication, flip the second fraction. Always the second one, not the first one. Divide the second one, because it's 3/5 divided by 2/7, which is different than 2/7 divided by 3/5. So in this case, flipping it around like this way wouldn't work. That's multiplication and division. Same rule applies for if it was just divide by like 4 again. You would want to make this over 1. Then go back and rewrite times 1 over 4. So if change this and flip this around, 3 times 1 is 3, 5 times 4 is 20, and I've got another simplified fraction, and that's your answer. Next, we will be doing some simplifying with not just numbers, but x's and y's and everything else. That's all.